Tonight we are going to look at parametric functions. Yeah, good evening everyone. You are all welcome tonight class. How are you and how was your day? I know it was stressful. How are you resting? Yeah, you are all welcome tonight class. Tonight we'll be talking about parametric function in calculus. Parametric functions in calculus. Amen. Yeah, I think the date is 28, right? 7-25. Okay. So it's simple as ABC. We'll look at it together. I'm going to explain it in details. Please don't forget to share, like, comments. Attendance is mandatory, and make sure you invite all your friends who are here to be in the class. I'll be very grateful. Amen. Hope you are seeing clearly. Okay. Yeah. Okay. Yeah. When we say parametric functions, parametric functions are functions of this form. It means it has two dependent variables. Parametric functions of this form: x either equals to t raised to the power 5 and y is equals to either sine 2t. We call these parametric functions. You understand? You can now see that we have a dependent variable here as what? X. Amen. We have an another dependent variable as what? Y. But you can now see that the independent variable in each of the equations are what? The same, true or false. So we can refer this as what? Parametric functions. Do you understand? They are always in this form and very easy and simple to differentiate as long as calculus is concerned. If you know the formula for differentiation, I don't think it will be, you find it difficult. Amen. Amen. Are you following? Hope you are following. Okay. Yeah. So far so good. So let's use this as what? An example. But before we use this as an example, parametric functions, we have a formula guiding these parametric functions. Is that clear? The formula is, since we are differentiating with respect to t and t, so the derivative will now be, since the dependent variable are what? X and y. So the derivative will now be dy all over the x is now equals to, we differentiate this with respect to t, right? So the y all over the t all over, we differentiate this with respect to what? T, right? the x all over the t. In other words, this is the same thing as dy all over the x is equals to dy all over the t divide the x all over the t. So this is the formula, either this one, go by this, or this one. Yeah. So this is the formula for parametric functions. Are you following? Do you understand? Any question? Any question? No. No question? So you mean we can proceed, right? Okay. So now let's proceed. Let us use this as our first example. Yeah? Amen? Okay. So what we do, we now say if x is equals to 5, x is equals to 3 raised to the power 5, sorry, and y equals to sine 2t. Amen? Okay. Yeah. And we now say find dy all over the x is simple as ABC, true or false. We write solution. Our x is equals to what? X is equals to 3 raised to the power 5, and y is equals to sine 2t. Amen? So what we need to do is we have to obtain our dx all over the t. It means we have to differentiate this function with respect to t, true or false. So if we differentiate this function with respect to t by the differentiation formula, this implies that what we have here, this is our n, then a here is invisible 1, true or false. Use this 5 to multiply whatever that is there. So here will be 5t raised to the power of 5 minus 1, true or false. Then this is the same thing as 5t raised to the power of 5 minus 1 is what? Raised to the power 4. So this implies that our dx all over the t is equals to 5t raised to the power of 4. Then, do you agree with me? Any question, please, before I proceed? Do you have any question? Do you have any question? Yes or no? Any question? No question? So we can proceed, right? Okay. So if you agree with me, let us consider this, that is the y all over the t. So we have to differentiate, this is a trig function, true or false. So if we are to differentiate sine 2t, if I were you, just consider what is here, 2t. So if you differentiate 2t, you are going to have, just differentiate 2t, you will have 2, right? Use this 2 to multiply. When you differentiate sine t, you are going to have cos t, true or false. But here we have sine 2t. So you are going to have, if you differentiate sine 2t, you will have cos 2t, true or false. But use this to multiply, so you are supposed to have, if you use this 2 to multiply the cos 2t, you are going to have 2 cos 2t. This is what you are supposed to have. Is that clear? So far, so good. So this implies that our dy all over the x will now be equals to dy all over the t divide or whichever way, or the x all over the t, which is equals, what is our dy all over the t is 2 cos 2t all over, what is our dx all over the t is this, right? 5t raised to the power 4. That is all. Any question? So therefore, our dy all over the x is equals to 2 cos 2t all over 5t raised to the power 4. Do you agree with me? Any question at this point before we proceed further to solve more examples? Do you have any question? Any question? Any question? Yes or no? Do you have any question? No question? So you mean we can proceed, right? Okay. So some people said there is no question. So this implies that we can proceed further. Is that clear? Let's proceed further. Let's proceed further. Let us proceed further. Amen. Okay. Find dy all over the x if x equals to, find dy all over the x if x equals to, okay, find dy all over the x equals to find dy all over the x if x equals to t minus sine t and y equals to 1 minus cos t. So when you come across questions of this form, do you need a prophet to tell you? No. You don't need a prophet. True or false? You don't need a prophet. So look at the functions. We have x equals to this, y equals to this. So it means these are what? Parametric functions, which you know how to go about. True or false? So let's write solution. Solution, our x is equals to t minus sine t and y equals to 1 minus cos t. Amen? Do you agree with me? Yeah. So if you agree with me, we are to differentiate this with respect to t. True or false? This function. So it means our dx all over the t. If you differentiate t, you are going to have 1. True or false? Then likewise, I told you when you see trig functions of this form, sine t, just after what is here, ordinarily if you differentiate t, you are supposed to have 1. True or false? Then, since it is sine t, if you differentiate sine t, you are supposed to have cos t. True or false? Use this 1 to multiply what is here. So 1 cos t is the same thing as cos t. True or false? But here we have minus, so here will be 1 minus cos t, then and dy all over the t will now be equals, if you differentiate 1 is a constant, true or false? Because of the independent, t is not attached to this one, is a constant. So whenever you differentiate a constant, what are you supposed to have? 0, right? Supposed to have 0. True or false? True or false? True, right? You are supposed to have 0. Yeah. So if you agree with me, it implies that here is supposed to be, then when you differentiate cos t, mind you, just after this, if you differentiate t, you are supposed to have 1. Then if you differentiate cos t, you are supposed to have minus sine t. Amen? So if you use this one to multiply minus sine t, this is supposed to be minus 1 times sine t. It's the same thing as minus sine t. True or false? So here, but mind you, we have minus sign here. True or false? So here will now be minus, open bracket, minus sine t. Amen? Then our dy all over dt will now, because minus times minus is what? Plus sine t. So far so good. The formula for parametric functions is our dy all over the x is equals to dy all over dt all over the x all over the t. Then this is equals to, what is dy all over the t? Dy all over the t is plus sine t all over, what is the x all over the t is 1 minus cos t. Then therefore our dy all over the x now be equals to sine t all over 1 minus cos t. Amen. Do you have any question, please? Any question? Yes or no? Any question? No question. It means we can proceed, right? We can proceed, right? Okay. There's no question. Let's move further to consider more examples. More examples. Amen. Okay. Now, there's no question. Let's move further to consider more examples. If x equals to exponential t sine t and y equals to exponential t cos t, find dy all over the x. Amen. Amen. Okay. So far, so good. I think we are progressing, right? We are progressing. Okay. Okay. Already we know that these functions are parametric, two of us. So let us write solution to solve it. Our x is equals to exponential t sine t, and y is equals to exponential t cos t, right? Okay. So if you agree with me, it means we have to find the x all over the t. But how do we find the x all over the t? You know, the function given here is not the usual function, true of us. We now have exponential t sine t. So it means this is how we are going to differentiate this function. We are supposed to use product rule. You know, in calculus, we have rules that are governing calculus. That is the basis of calculus. One, we have product rule. Two, we have quotient rule. Three, we have chain stroke substitution rule. Amen. Or it is also known as function of a function. So it implies that chain rule or substitution is also known as function of a function. But they are always of this form. Product rule is always in this form. The equation is y equals to uv. It means this is one function, this is another function. It means functions, when we say product, you suppose know in mathematics, product means what? Multiplication. So if two functions are multiplying each other, you don't need a prophet to tell you. It means you are supposed to use what? Product rule, true or false. Then, and that is the formula is, I'll write it for you. This is the formula for product rule. Our dy all over the x is equals to u dv all over the x plus v du all over the x. This is the formula for product rule. Then this quotient rule, when we say quotient in mathematics, hope you are following. Any question? When we say quotient in mathematics, quotient means division. Quotient means division. Take note. So it is always in this form, u all over v. It means whenever you see functions dividing each other, this is what you are supposed to use, u all over v. Just like when you have, like what we solved, we got, okay, when you have, let me say, 2 sine t all over 5t raised to power 4. Yeah. Note that you don't need a prophet to tell you. Why? Because this is a function, this is another function. So you can now discover that this function divides this. So if you are asked to find the y all over the x, it means you go straight to make use of what is called quotient rule. Amen? So quotient rule, the formula is our dy all over the x is equals to u dv all over the x minus v du all over the x, then all over v squared. This is quotient rule. Then chain rule is you that will form the formula for chain rule. Is that clear? That is chain rule for you. Are you following? So just take note of these two. Then in class, I'll come back and take them thoroughly. Is that clear? Do you understand? Any question? Any question? No question. It's okay. So let's proceed further. Amen. Amen. Okay. So as I was saying, it means what we need here is product rule. But you know, I will teach you the fastest approach. If without product rule, you can just differentiate it direct. Is that clear? So look at it. This is the function, right? Since we want to differentiate this function, what you would do, here is what? Here is x equals to exponential t sine t, right? Okay. So now, if I were you, out of these two functions, this is one function, this is another function, true or false? So which one do you want us to hold as constant? Okay, let us hold this one constant. So that without using product rule, you will see the product rule, right? So that, if we differentiate this, it means our dx all over dt will now be equals to, if we differentiate exponential t, we are still going to get exponential t, true or false? Then use it to multiply this one that you said you hold as what? A constant. It means exponential t times, what is there, sine t, right? So it will still give you back exponential t sine t. You know this formula here, this is plus. Let me write it out for you. This is product rule formula. It means y equals to u v. This is equals to our dy all over dx is equals to u dv all over dx plus v du all over dx. This is the formula for product rule, and you will see that we are going to have this. So now here is what? Plus. So we now write plus. Then we hold this one first, true or false. We differentiated this exponential function. So which one are we going to hold now? It means we are going to hold the exponential, then differentiate sine t. So any answer we get, use it to multiply the exponential. So let's do it together. So this implies that if you differentiate sine t, you are supposed to have cos t. So exponential t times cos t. We are going to write exponential t times what? Cos t. Can you see? We have gotten our product rule. Without I just differentiate it direct to obtain our product rule. Is that clear? Do you have any question? Any question? Amen. Okay, if there is no question, it means I can proceed, right? So it means our ds all over dt is this. Then let's consider this dy all over dt. Dy all over dt will now be equals to, okay, let me just write y is equals to exponential t, cos t, right? So our dy all over the t supposed to be hold this cos t constant, then differentiate exponential t. Easy to multiply cos. If you differentiate exponential t, you still get back exponential t times cos t, then plus, at this point we are going to hold what? Hold this, then easy to multiply, hold this exponential, then differentiate this. If you differentiate cos t, what are you supposed to have? You are supposed to have minus sine t. So easy to multiply this, it means exponential t, open bracket, minus sine t. Because if you differentiate cos t, you are supposed to have minus sine t. Then easy to multiply the constant back. Amen? Are you following? Do you understand? So now what we need to do, thank you so much for sending me stars and the rest. God bless you guys. So now what we need to do here is use this minus to multiply this plus. So this implies that we are supposed to have dy all over dt now equals to exponential t cos t, then minus exponential t sine t. True or false? Then let's consider our formula. Let's record the formula. I think we can clean here. Let us record the formula. So here will now be equals to our dy all over dx is equals to dy all over dt all over dx all over dt. Then our dy all over dx will now be equals to, what is dy all over dt? Dy all over dt is this exponential t cos t minus exponential t sine t, right? Then all over, what is dx all over dt? Is this exponential t sine t plus exponential t cos t, right? As you can see, something is common. We can factor it out. Look at the board very well. Somebody should look at the board very well. Look at the board very well. Look at the numerator. We can factor out exponential, true or false. So our dy all over, yes, will now be equals to exponential t, open bracket, cos t minus sine t, then close bracket, exponential t, open bracket, sine t plus cos t. Amen? So this and this will cancel. So at the end of the day, we are going to have final answer will now be dy all over dx is equals to cos t minus sine t all over sine t plus cos t. So this is what you are supposed to have. Amen? Any question? Do you have any question? Any question? Yes or no? No question? It means we can proceed, right? No question, right? Can we proceed? Can we proceed? We can proceed, right? We can proceed, right? Okay. Let us proceed further to solve more examples. Let's proceed further to solve more examples. Okay. I want to solve application. Amen. I want to solve some applications. It says the position of a particle that is moving along a curve is given. The position of a particle moving position of a particle moving of a particle that is moving, that is moving along a curve is given at time t. Moving along a curve is given at time t. Hope you are seeing what I am writing. At time t, along a curve is given at time t by the parametric equations. T by the parametric equation. X equals to 2 minus 3 cos t. X equals to 2 minus 3 cos t, comma y equals to y equals to 3 plus 2t, 2 sine t, 3 plus 2 sine t. Amen? Where x and y are measured in feet and t in seconds. Where x and y measured in feet right, and t in seconds, and t in seconds. Full stop. Hope you are seeing what I am writing. Okay? Okay. One of the questions says, find A, the time rate of change of x. Find, A, the time rate of change of x when t equals to pi all over 3. Pi all over 3. Okay. B, the time rate of change of y when t equals to the time rate of change of y when t equals to B. Write it down. The time rate of change of y when t equals to pi all over 5, right? Am I right? Oh, 5 pi all over 3, sorry. 5 pi all over 3. I think there are 3 questions. I'm not going to solve C here. I will leave it as an assignment for you before we round up. So that will be an assignment. I'm going to collect it tomorrow. Is that clear? Hope you are seeing. So let's put our heads together to consider this question. As simple as ABC is very simple. Okay, so far so good. It is not difficult. It is not difficult. It is not difficult. Okay, we write solution, right? Here is, you know, our function x equals to the parametric function minus 3 cos, sorry, this is cos t, and y equals to 3 plus 2 sine t. Amen. So now what we need to do, question A says the time rate of change of x when t equals to what? It means we are going to concentrate on this equation, this parametric function. Is that clear? Because A is referring to this because of what? Change of x. You know, when we say change of x, do you know that the y, the x all over the t, this is the same thing as change in x. You don't know? This is change in x. Do you understand? So this the x all over the t is the same thing as the time rate of change of x is referring to this. So what we need to do here is we have to differentiate this function with respect to t. And look at this function. Here is 2. Already is a constant. So it's going to be what? 0. True or false? Then when you differentiate cos t, you are supposed to have minus sine t. This is to multiply this minus. It's going to be plus. So here our dx all over the t will now be equals to, differentiate 2 is 0, then differentiate minus 3 cos t. You are going to have minus 3 open bracket minus sine t. Amen. So this implies that the x all over the t will now be equals to minus times minus plus sine t. Do you understand? So now let us now recall that at t equals to pi all over 3. Is that clear? At t equals to pi all over 3. At t equals to pi all over 3. So if at t is equals to pi all over 3, this implies that here our dx all over the t now be equals to 3 sine pi all over 3, then sine pi all over 3 is equals to what? Square root of 3 all over 2. Square root of 3 all over 2. So if you agree with me, here will now be sine pi all over 3 is equals to 3 square root of 3 all over what? 2. Because pi is what? 180 all over 3. So 180 all over 3 is what? Is it not 60? 60 degrees. True or false? Yeah. Okay? So that is that. This is what you are supposed to have. Then let's come to consider y. That is our B part of the question. This is A. Excuse me. B part of the question says the time rate of change of y when t equals to what? 5 pi all over 3. So if out of these two equations, these two functions, which one is this question referring to? Find the time rate of change of y when t equals to. It means the rate of change of y is the same thing as dy all over what? Dt. Because it has to in respect to what? Time. Your time is t in seconds, true or false? Do you understand? Are you following? Okay. So if you are following, attendance is mandatory, very important. So if you are following, this implies that we have to differentiate this function. That is y is equal to 3 plus 2 sine t. Amen. So this implies that our dy all over dt is now equals to, already this is a constant 3. So it's going to be 0. Now when you differentiate sine t, you are going to have cos t. Easy to multiply this constant here. So here will be 2 cos t, true or false? Then it says at t equals to 5 pi all over 3, true or false? So this implies that the y all over the t now be equals to 2 cos, open bracket, 5 pi all over 3. Amen? Do you understand? Are you following? So cos 5 pi all over 3. Yeah, we've not finished. Sorry about it. They said here where x and y measured in feet, then t in seconds. So we are supposed to write feet per second. Yeah. Do you understand? Take note. Then, so here, look at this. Cos 5 pi all over 5 pi all over 3. 5 pi all over 3 is half. Amen. The y all over the t is equals to 2 times cos 5 pi will give us 5 pi all over 3 will give us 1 all over 2. 1 all over 2. So far so good. So this implies that this is 5 times 180 all over 3, 60. 60. So which is 360, right? So cos 360 is what? Half, right? 1 all over 2. Then here is going to give us, this is equals to, this will cancel, 1 feet per second. 1 feet per second. Yeah. 1 feet per second. I think I'm right. So this is what you are supposed to have. Any question? Do you have any question? Any question? Yes or no? It is not clear. It is not clear. It is not clear. Okay, look at it very well. Look at it. Look at it very well. Are you seeing it? Can you see it? Are you seeing it? Can see it clearly. Can you see it clearly? Can you see it clearly? You can see it clearly, right? Okay. Yeah. So far, so good. Our time is almost up. So let me give you the C part of the question. I'm going to collect it tomorrow. C. C part of the question says, the the time rate of time rate of change of the angle of inclination of the angle of the inclination of the angle of inclination theta inclination theta of the tangent amen, line, tangent line, when t equals to 2 pi, line when t equals to 2 pi all over 3. Think so? When t equals to 2 pi all over 3. Hope you are seeing it very well. You are seeing it very well. This is your assignment. The C is your assignment. This is your assignment. Look at it very well. C is your assignment. And I'm going to collect it tomorrow. Try and do it this night. The time rate of the angle of inclination theta of the tangent line when t equals to 2 pi all over 3. Yeah, gentlemen and ladies, I'm always grateful for your time. Thank you and God bless you all. Please don't forget to share, like, comment. It's very important. I'm very grateful. So tonight we are going to call it a day. Is that clear? We continue our online class on Saturday, same venue, but the time is going to be 8 to 9 in the morning. Please always be available. Thank you and God bless you. Love you guys. Bye. Try and do your assignments. Take care. Bye.